All right, let's get into it. Today, we're not just learning a few new SQL commands. No, we are going to fundamentally change the way you think about SQL. It's a pretty small shift in your mindset, but trust me, it unlocks a massive amount of power in your queries.
So let me ask you a question. When you're writing a query, what's actually going on in your head? Are you picturing the database chugging along, looking at one row, then the next, like it's just going down a list? Hey, if that's you, you're not alone. But there's a much better way to see it.
And here's the answer. This is the big reveal. SQL doesn't think about individual records, one by one. It thinks in entire collections or sets of data, all at once. And I'm telling you, internalizing this one simple idea is the absolute key to going from a beginner to an advanced SQL user.
So, what does this actually mean in practice? Well, understanding this concept is really like getting the keys to the kingdom. It explains why certain queries are fast, why others are slow, and how you can write these incredibly elegant solutions to really complex problems.
Now, if you wanted to get technical, and we're all a little nerdy here, right? The formal term for this is relational algebra. It's the mathematical foundation that SQL is literally built on. And its core principle is operating on entire tables, or relations as they're called, as a single unit, not looping through them one by one.
But let's just forget the fancy math. Let's explain it like you're 5. Forget tables and rows for a minute. Just imagine you have a box of red balls and another box of blue balls. Set-based thinking is just asking questions about the entire boxes. Can I dump them all together? Can you show me only the balls that are somehow in both boxes? Or how about just the red ones that are definitely not in the blue box? That's it. That's set theory in a nutshell.
Okay, so if SQL thinks in sets, how do we speak its language? Well, we use these 3 fundamental tools: union, intersect, and accept. You can think of these as your primary verbs for combining and comparing your big boxes of data.
Let's start with the most common one, union. Now, here's the critical difference between union and its sibling, union all. A regular union combines 2 sets, and then it does all this extra work to sort them and remove any duplicates. Union all, on the other hand, just stacks the 2 sets together, duplicates and all. That no extra work part makes it way faster. And this brings us to our first golden rule, and you should probably write this down. Always default to union all. Performance matters a lot. The only time you should be using the more expensive union is when you have a clear, specific, conscious reason to find only the unique values. Next up is intersect. This one is super simple but really powerful. It looks at 2 sets and gives you back only the items that appear in both of them. It's the pure overlap. In our little analogy, it's finding the cities that are written down in both of your notebooks. And the final tool in our basic kit is accept. This kind of does the opposite of intersect. It takes everything from the first set and then just removes anything that also appears in the second set. You're basically asking, what's in box A that is definitely not in box B? This is incredibly useful for finding things like customers who bought something this year but didn't buy anything last year.
All right, let's level up. We've got the basic tools down. Now let's talk about making smarter, more efficient choices in our queries. And this brings us to a classic debate: in versus exists.
This comparison really gets to the heart of how these 2 operators think differently. The in operator, it first builds a complete list from your subquery, and then it checks each outer row against that entire list. Exists, though, works differently. For each outer row, it just peeks into the subquery and asks, hey, can you find me at least one match?
And this right here is why exists is so often the performance winner. The moment it finds that first match, it just stops. It returns true and moves on to the next row in the outer query. It doesn't waste time scanning the rest of the inner table. That whole short-circuiting logic is incredibly efficient, especially when you're dealing with large tables. So here's our second golden rule. If you're checking for something against a large table or a complex subquery, your default should just be exists. If you're just checking against a small, hard-coded list of values, like a few country codes, then IN is perfectly fine, and honestly, it's often more readable.
Ready to unlock some real SQL superpowers? Now that we understand the basics of set-based thinking, we can explore 2 really advanced techniques: lateral joins and pivot. These solve some very common but very tricky problems with incredible elegance.
A lateral join is a total game changer. See, normally a subquery in your from clause can't see the other tables. It's totally isolated. Lateral breaks that wall down. It lets you run a customized subquery for each and every row of the table that comes before it. The mental model is run this subquery for each row.
It's perfect for solving that classic problem of find the top 3 most recent posts for each user. Okay, now let's look at another common challenge, transforming the shape of your data. Databases love storing data like this, in a long format, where you've got 1 row per month. It's efficient for storage, but for reporting, this format can be a real pain. Your boss wants to see January, February, and March side by side, not in a long list.
And this is the magic of Pivot. It's a pure set-based operation. You're telling SQL to take the entire set of month values and use them to define a new table structure. It transforms those distinct values, January, February, March, from being rows into being new columns. It's an incredibly powerful way to reshape your data for analysis without writing a single loop.
Okay, we've covered a lot of ground, from the basic tools to some advanced superpowers. So let's bring it all home by focusing on how this set-based mindset helps you write better, safer, and more efficient SQL every single day.
You know, when you don't think in sets, you fall into these common traps. You use the slow union by default. You write a not-in query that just breaks the second it encounters a null value. You slap a select distinct on a messy join to hide the real problem instead of fixing it. Each of these mistakes really stems from thinking row by row instead of thinking about the behavior of the entire set.
So if you take only one thing away from this whole explainer, let it be this. The next time you sit down to write a query, just stop. Stop thinking about loops in individual rows. Start thinking about your tables as boxes of balls. Think in whole sets. Because SQL is not about rows. SQL is about sets. Master that, and you will master SQL.